morning, one and all present here. We'll be presenting our presentation today on the topic of AWS IoT, developing and deploying of Internet of Things. We have completed a course on this, and I'll be starting with the introduction for the same topic. Okay. First, let us see what is AWS IoT. It is an Amazon Web Service platform that basically collects and analyzes data from internet connected devices and sensors, connects that data to AWS cloud applications, as we have all seen at the beginning of our curriculum and course. AWS IoT can collect data from billions of devices and connect them to endpoints for other AWS tools and services, allowing a developer or user to tie that data into an application. And AWS user accesses AWS IoT with the AWS Management Console, software development kits, or the AWS command line interface. An application accesses the service through AWS SDKs. AWS IoT APIs are divided into the control plane, which includes service configuration, device registration, and logging, and the data plane, which includes data designation. AWS IoT basically supports the HTTP, Mqtt, and WebSockets communication protocols, as we have all seen in our modules, between connected devices and cloud apps through the device gateway, which provides secure two-way communication while limiting latency. The device gateway scales actually automatically, and it removes the need for an enterprise to provide or manage the servers for a pub or sub messaging system, which allows clients to publish and receive messages from one another. Moving ahead, we'll see what are the AWS IoT core services and what exactly is AWS IoT core. IoT devices offer several efficiencies. However, we must also consider the environment impact. So we all know there are different environment that keeps on impacting this user while he is on the system. Devices must be manufactured and shipped and installed. They consume energy during operations, and they must eventually be disposed of. They are also a challenge to maintain. An expert may need physical access to the device to diagnose issues and update it. So this especially occurs for smaller and cheaper devices because they have extended device support, and there are a lot of enhancements that are not feasible economically for a lot of users, which results in more frequent device replacements. So basically, AWS IoT Core is a managed cloud service that lets connected devices easily and securely interact with cloud applications and other devices as well. AWS IoT Core can support a billion of devices and trillions of messages and data, and can process and route those messages to AWS endpoints and to other devices which are reliable and secure. Next, we'll see, we will have a look now at AWS Cloud 9. With AWS Cloud 9, you can write, run or debug code with a browser. It includes a code editor, debugger and terminal, as we all must have experienced some time. Cloud 9 comes pre-packaged with essential tools for popular programming language. Basically, it is an integrated development environment, as said before by me, that the system will set up an environment for itself. Now, what exactly is an environment and why is it created? So an environment is a collection of AWS resources running an application version. Each environment runs only one application version at a time. However, you can run the same application version or different applications in many environments simultaneously. You can change also your environment type to a single instance or load balanced or scalable environment by editing your environment's configuration just at the start of your datas. Lastly, I'd just like to say that AWS is a complete package, AWS IoT, that offers a free tier of service Beyond that tier, customers charged according to the number of published messages and the type of data he is going to deliver. That's all by my side. The next slides will be presented by my teammate Hemant. Hemant, you can carry on.
Yes. So good morning everyone. My name is Hemant Borse and I am going to talk about the rest of the presentation for today. And let's start with AWS IoT Shadow. Now what is basically Shadow is that with the help of AWS IoT core, we can create a virtual version of device shadow of each device that includes the device's latest state. Like for example, as we have learned about stateful and stateless protocols. So here we are taking the latest information and the data of the device and we are also updating it and deleting it using MQTT and HTTP protocols. And a device shadow is just like a JSON, that is Java scripted notation that is used to store and retrieve current state information for a device. And shadows provide a reliable data store for devices, that is apps and other cloud services to share data. They enable devices, apps and other cloud services to connect and disconnect without losing a device's state or the device's previous information as well. And with the help of HTTP protocols and RESTful APIs, we can use the methods such as update, get and delete. With the update method we can update the device's state, and with get method we can retrieve the device's latest state, and with delete method we can delete the device's previous state or latest state depending on the requirements of it. And the device shadow is the last reported state and future state of each device when it's offline. And starting with the rules of AWS. Next slide. Next slide, please.
Is it visible, Hemant?
Yeah, you just went very pretty much forward. Back. Yes, rules and SDKs. When we talk about rules, when two devices in IoT are communicating with each other, there is a need for business rules as well. And these rules are particular protocols or rules which are followed by devices to ensure proper communication and security as well. So what are rules? Rules are analyzed and actions are performed based on the MQTT topic stream. As we have heard about MQTT, MQTT is called as message queue telemetry transport, which is based on publish subscribe model. And the broker breaks the data and information into small packets called as topics, and these topics are sent to dedicated subscribers and clients only. So the SQL statement allows you to extract information from an incoming message, and the topic filter for AWS IoT rule specifies one or more topics. And from rules and with the help of rules we can rules engine makes it possible to build IoT applications that gather, process, analyze and act on data generated by connected devices at global scale without having to manage any infrastructure or hardware requirements of the device. And basically talking about the rules in a brief summary, it gives your devices the ability to interact with other AWS services as well. And with the help of AWS we can ensure that the devices are communicating properly, and some business rules are also followed and abided. And if we look at Amazon S3 SDKs, Amazon S3 is called as Amazon Simple Storage Service, which is called as Amazon S3. It is a web service that provides a highly scalable cloud storage. That means we can increase the size of the storage and we can also decrease it. That means we can upscale it and downscale it as well. And Amazon S3 provides easy to use object storage with a simple web service to interface to store and retrieve any amount of data from anywhere on the web. And it basically allows you to programmatically interact with AWS IoT services, also keeping with the storage in consideration. Now getting to the next slide. Next slide, please. Next slide. Yes. Now as we have talked about the rules and the SDKs and shadows, the security is also important as well. And cryptography methods using AWS IoT are also really important to be taken into consideration. So what is IoT security? In AWS IoT for devices using MQTT to communicate, this is done with an X.509 certificate. And there are different methods of cryptography in AWS, which is uh, symmetric cryptography and asymmetric cryptography as well. And in symmetric cryptography, one can have a key to encrypt, decrypt, lock or unlock the data. That is, when we are sending a particular message to a particular client or a subscriber, then that client or subscriber is already having the key to encrypt, decrypt or lock and unlock the data. But when it comes to asymmetric encryption, both senders and receivers are having their public keys and private keys, so that public keys and private keys, so that more secure protocol of communication can be established. And now when we talk about Amazon free RTOS, as we know that each and every IoT device or electronic device is not it is not necessary for them to handle large applications or huge applications. Some IoT devices are also limited by their hardware constraints or their hardware limitations. And if we talk about Amazon free RTOS, it is an operating system for microcontrollers that operates the low edge devices or devices with smaller constraints, such as, for example, our Fitbits, our fitness trackers and pacemakers, and small electronic devices. Small electronic devices which only require 64 KB of RAM to operate. So basically, it gives them a free operating system, and a user interface, so that users can interact with the particular IoT device easily. And if we talk next slide, please.
This one, right, Hemant?
Yes. Now, as we have learned about the MQTT in AWS, MQTT is basically, as I told you, it is called as message queue telemetry transport, and it is a pub/sub model, and the broker breaks the topics and sends it to the required publishers or required subscribers and clients. So now, why it is the reason that MQTT is preferred more over the WebSocket protocol in AWS. So basically, AWS IoT supports over the WebSocket protocol to enable browser-based and remote applications to send and receive data from AWS IoT connected and devices using your AWS credentials, which you use in AWS Management Console. And the WebSocket support is available on TCP port 443, which basically allows messages to pass any kind of firewalls or proxies, which is not preferred sometimes. And that's why MQTT is preferred more over the HTTP HTTP protocols or WebSocket protocols in AWS. And that's why it is the most widely adopted lightweight messaging protocol designed for constrained devices. As I told you about constrained devices in the security section, that's why it is more important. And AWS IoT message broker implementation is based on the MQTT protocol. And if we go to the next slide now. As we have learned about the various protocols and the various procedures in AWS, now how we can deploy a particular Internet of Things. As we can see here, here is an example of Amazon Deep Lens, that is AWS Deep Lens, which is a deep learning enabled video camera optimized to run machine learning models and perform interfaces on the devices. And it is not necessary that we should have that Amazon AWS Deep Lens camera with us. We can also implement it in software using the AWS Management Console as well. And with using proper programming techniques, we can create an AI camera which can identify and learn particular things. For example, as we know about Google Lens and the QR code scanners in our phones, they are a great examples of AWS Deep Lens cameras. And the features, if we look from the hardware point of view, what are the features and requirements of AWS deep lens cameras? It is having an ARM processor, that is Intel processor, a 4 megapixel camera, and it supports 1080p resolution, and is also having green grass features. Now, what is green grass? Green grass is basically an extension of Amazon FreeRtos. That is basically just basically more like a more helpful version of Amazon FreeRtos for devices with smaller hardware constraints, and the bandwidth required is less, and it is also having certificate-based authentication, as I discussed earlier in the IoT security. It is having .x509 certificate security, and it is also enabled with Wi-Fi, so that it can be connected to the internet and disconnected as well. And now moving on to the conclusion, that is the last slide, that is IoT Analytics. Next slide, please. Yes, sir. So basically, as we have learned about the communication of different devices in AWS, it is also necessary to learn the performance data and analyze that how the devices are performing when communicating with each other. So basically, AWS Analytics is a fully managed service that makes it easy to run and operationalize analytics on the massive volumes of IoT data without worrying about the cost and complexity. And basically, it is the easiest way to run analytics on IoT data and get insights to make better and more accurate decisions for IoT applications and machine learning cases as well. And sometimes AWS IoT Analytics service is because the IoT data should not be corrupt, and it should not be highly structured, and it should have significant gaps as well. So with that being said, thank you so much for listening to this presentation.